lines. We're going to talk about lines, but actually indirectly talk about lines. We're actually going to talk about the angles formed by lines. And we're going to just start with just a very simple review of some lines here. Let's not forget what these things are. Here I've got perpendicular lines. Line M here and line N intersect at a 90-degree angle. That's what that little square is to indicate a 90-degree angle. That then is described as perpendicular lines. Two lines that intersect and form a series of 90-degree angles. Then I've got two lines here that will never intersect. We know that from the tick marks. Tick marks important in geometry because they're a way to indicate stuff are either congruent to each other in different areas that we might not realize that there's congruency. We write this P and then two straight lines and Q to say that they're parallel. Parallel indicates that then those lines will never intersect to form the angles that we're going to look at soon. As I said before, we're going to talk about lines, but we're actually talking about the angles that they make. So here's two kind of systems of lines put together here so we can see the angles that they form. Here we've got two parallel lines and a line that crosses it, and each one of these numbers here indicates an angle. So we have angle 1, angle 7, angle 4, angle 6. Over here we've got two parallel lines, M and N, and they're cut by line P and line Q, kind of the set of lines that we had from the first slide. Two parallel lines and then two lines cut in a perpendicular. And what we're going to be doing then today is just classifying these. We're just going to be talking about what types of angles these are in relation to each other. So let's look at that now. Let's start with the transversal. So the transversal is the line that's going to cut across those two lines. So by definition, it is the line that intersects two or more lines. Now for our purposes, our transversal is going to cut parallel lines. And because of that, then all the relationships that we talk about next in terms of the angles will be true. Because this transversal will cut parallel lines, these relationships will be true. What we should also know about these relationships is that the relationships that we're discussing now are congruencies. So when we talk about these angles in terms of their relation to each other, we're going to say that they're congruent to each other. Now congruent has a meaning and it has a symbol. Congruent means that these two shapes, these two figures, are the same. And we would indicate that with an equal sign and then the wavy line on top. That's what congruency is. So let's get into classifying these angles. When we classify these angles, we're looking at location. Because it's location, location, location. That's what matters. So let's just start by talking about interior angles. Now when we talk about interior, we're talking about inside the parallel lines. So when we're inside the parallel lines, any line, any angle inside the parallel. Let me use the symbol for parallel. So any angle inside the parallel. So in here we'd have angle 4, angle 3, angle 5, and angle 6. All four of these are interior angles. Now that's just location. Let's talk about relationships then. If we look at the relations of those, we have a thing called alternate interior angles. And alternate interior angles are, get that, interior angles that are on opposite sides of the transversal. Opposite sides of the transversal. So when we look back at this, I've got my four interior angles. I have two sets of alternate interior. So angle 4 and angle 6. So angle 4 is congruent to angle 6 because they are alternate interior angles. Two angles on the interior that are opposite each other on the transversal. Okay? And then there's two more. Let's go with purple. And I've got, you probably know this already, I got angle 3 and angle 5. So angle 3 is congruent to angle 5. Two angles opposite the transversal. They are congruent to each other, and we classify that with the words, so put this on your file folder, alternate interior angles. Keep that idea of congruency going, so I'm just going to put congruent back up here. Congruent, G-R-U-E-N-T, and the symbol for congruent, that equal sign with the wavy lines. So we have 3 more sets here of what we're going to be talking about in terms of vocab. I've got exterior angles. Those are angles. Not angels, angles. L-E-S. That are, get this, outside the parallel. I've drawn the symbol for parallel. Outside the parallel lines. So we're talking about 8 and 7 and 1 and 2. All of those sit outside the interior of those 2 parallel lines. And then from there, that's just location. From there, we've got alternate exterior angles. Very similar sounding title as what we saw on the last slide, but alternate exterior angles are angles, A-N-G-L-E-S, that are exterior, of course, because exterior, angles opposite you said. That was pretty quiet. I think you can do better than that. Opposite the transversal. So when we look at these, we can just pick those out. We want to be exterior, alternate exterior. So if I pick out 2 first, angle 2 and angle 8 have that relationship. So that means that the measure of angle 2, or angle 2, is congruent to angle 8. There's one more set there that was created by that transversal. I got angle 7 and angle 1. So I've got angle 7 is congruent to angle 1. Kind of running into stuff there. I got one more definition for you before we try some actual classifying. Let's look and see what it says here. I got corresponding angles. So corresponding angles are 2 angles, A-N-G-L-E-S, wow, I have trouble with that, in the same position on the 2 lines in relation. This is a really good marker. To the, I'll say it this time, transversal. 2 angles in the same position on the 2 lines in relation to the transversal. Please try that at your dinner table tonight and see how that goes over. So if I have this one here, angle 1. Now I want to find the same angle that's in the same position in relation to the 2 lines down here. So it's either going to be 5, 6, 8, or 7. And judging by where it is in relation to the transversal and the line, it has to be 5. So because those are corresponding angles, I think I spit a little bit there, sorry. The measure, and that's what this M means, the measure of angle 1, and I just haven't written the M's up here, but the measure of angle 1 is congruent to the measure, the measure of angle 5. Those 2 angles are congruent. They are the same. Therefore, the measure of angle 2 is congruent to the measure of angle 6. The measure of angle 8 is congruent to the measure of angle 4. Put my little wave on there. And lastly, I've got the measure of angle 7 is congruent to the measure of angle 3. Measure of angle 3. Let's try a couple. Congruency. Remember, as we're naming these things, they are congruent to each other, which means they are the same angle. Let's look at the first one. We're just classifying today. Classifying the measure of angle 2 and the measure of angle 8. Here is the measure of angle 2. Here is the measure of angle 8. Let's check location. Are they inside or outside of the parallel lines? They are outside, which means we have Oh, we have to check something else, right? They're not just outside. They're outside and they're opposite each other on the transversal, which makes them alternate. This is a bad marker. Let's try this straight up red. Alternate on the outside, exterior angles. Now in the next lesson we'll talk about how we can decide what their measure is. Now I've got angle 4 and angle 6. I'm going to go in with the red here. I got the red 4 and the red 6. Let's check location. Are they inside or outside? They're definitely inside. Are they on the opposite sides of the transversal? Yes, which makes them alternate. Interior angles. Now we got one more. Gosh, there's 3 examples for classifying, so I wonder which one this one's going to be. We got angle 1 and angle 5. Let's clean off our grid here. We got angle 1 and angle 5. Okay. Are they both on the interior? No. Are they both on the exterior? No. Are they in the same place in relation to the 2 lines? This one is in that angle, this one is in that. They are. So angle 1 and angle 5 then are corresponding angles. So in the future we'll know they're corresponding, which means that they're congruent. Now let me just throw something out here and say, what relationship does the measure of angle 6 and the measure of angle 1 have? If I look at the measure of angle 6 and the measure of angle 1, are they interior? No. Are they exterior? No. Are they corresponding? No. So what we know about them is there is no relationship. When we see that, we would state there is no relationship between those 2 angles. Okay. We're going to be classifying angles using a transversal that cuts up parallel lines. That's why we call it lines, of course, right? That makes sense. Good luck.